What happens when a leader's ego overrides the laws of physics? King Gustav's flagship, the Vasa, sinks 20 minutes into her maiden voyage on this day. I am standing in the Stockholm harbor, holding a piece of her waterlogged oak hull. Behind me, thousands of horrified spectators watch the pride of the Royal Navy vanish completely. This wasn't a tactical military defeat. It was an entirely preventable, self-inflicted architectural collapse. Today, we look at this disaster and laugh at the incompetence of 17th century engineers. But the exact same pattern of failure is destroying your modern software projects right now. To understand why, we have to go back to the shipyard where the Vasa began. The original specifications were clear, well documented, and perfectly balanced for a standard artillery galleon. The master shipwright knew exactly what he was building, and the math was completely sound. I am tracing the original ink lines on this heavy parchment blueprint from the archives. You can see the exact moment where the project's scope fundamentally detached from physical reality. King Gustav demanded an unprecedented second tier of heavy bronze cannons midway through the construction. He wanted the most heavily armed ship in the world, ignoring the original physical constraints. The hull was already built. The foundation was set. The center of gravity was fixed. Adding a second gun deck high above the waterline completely invalidated the core structural mathematics. I am touching the cold, ornate metal of one of these massive bronze artillery pieces. Each cannon weighed over a ton, and the king demanded 60 of them on board. The shipwrights were terrified. They knew the vessel would be dangerously top-heavy and compromised. But you do not tell a 17th century monarch that his visionary request is impossible. So, the engineers silently complied, modifying the upper decks while leaving the narrow hull unchanged. This is the exact moment a project shifts from engineering reality to pure executive fantasy. They added tons of heavy oak and bronze to the highest possible point of elevation. Before the launch, the Naval Command conducted a basic physical stability test at the mooring. 30 men ran side to side across the upper deck to measure the lateral roll. I stand on the dock, watching the massive wooden structure lurch violently back and forth. After just 3 runs, the test was abruptly canceled because the ship almost capsized completely. The objective data was screaming that the system was fundamentally unstable and doomed to fail. The Admiral witnessed this terrifying test with his own eyes. The evidence was absolutely undeniable. But the king was waiting. The stakeholders were impatient. The launch date was already finalized. So, they ignored the critical testing data and ordered the doomed vessel into the water. They hoped that somehow, sheer willpower would rewrite the laws of physics and fluid dynamics. It took exactly 1 light gust of wind to push the top-heavy ship over. Water rushed into the open lower gun ports, and the flagship sank into the mud. The master shipwright died of a stress-related illness before the launch, escaping final blame. The king blamed the builders. The builders blamed the king. The ship remained underwater forever. Now, let's bridge this disaster directly to your modern technology and business architecture system designs. How many times have you been handed a finalized software blueprint with a fixed deadline? And how many times has an executive suddenly demanded a massive new feature midway through? They want an unprecedented second tier of functionality, but they refuse to move the deadline. They refuse to expand the foundational architecture to support the massive new weight of code. You know the system will become top-heavy, brittle, and mathematically guaranteed to crash soon. But you do not tell the visionary CEO that their brilliant new integration is impossible. So, your engineering team silently complies, stacking heavy new features on a narrow, fragile backend. You run the beta tests. The latency spikes violently. The server load becomes dangerously unstable. The objective metrics are screaming that your digital ship is going to capsize in production. But the marketing campaign is ready. The board is waiting. The release date is locked. You ignore the critical testing data, push the code to production, and hope for miracles. It takes exactly 1 light gust of user traffic to bring the entire system down. The servers crash, the database corrupts, the project sinks into the mud of technical debt. I know this pattern intimately because I built my own Vasa early in my career. We were building a scalable entertainment platform, and I demanded a complex live streaming feature. I ignored my lead architect when he warned me about the fundamental database load distribution. We launched it anyway, and the entire platform collapsed under the weight of concurrent users. It cost us millions of dollars and permanently damaged our reputation with key early investors. I was the King Gustav of my own startup, sinking my flagship through pure arrogance. Scope creep is not just a minor annoyance. It is a systemic architectural death sentence. Forcing late-stage features onto a fixed foundation means you are destroying the core structural integrity. You cannot negotiate with the laws of physics, and you cannot negotiate with computational limits. The most dangerous phrase in modern business is, just add this one quick thing now. Every quick addition changes the center of gravity, shifting the entire project's risk profile completely. The engineers who built the Vasa were not stupid. They were trapped in broken systems. They lacked the psychological safety to tell the ultimate stakeholder the hard, undeniable mathematical truth. In your organization, who has the absolute authority to stop a launch when tests fail? If the answer is nobody, you are building a ship that is guaranteed to sink. You must establish an objective threshold for stability that no executive is allowed to override. If the lateral roll exceeds the safety margin, the launch is cancelled with no exceptions. If the server latency spikes beyond the acceptable threshold, the deployment is halted immediately. Period. We must separate the engineering reality from the stakeholder fantasy before it reaches the water. I am putting down this piece of the Vasa hull and leaving the dark shipyard. Next time you are asked to add a second gun deck to your project, stop. Look at the foundation you have built and calculate the true cost of the weight. Show them the stability metrics. Show them the violent lurching of the beta test servers. Demand the time and resources to widen the hull before you add another heavy cannon. It is better to have a delayed, functional ship than a punctual, catastrophic naval shipwreck. Do not let executive pressure force you to ignore objective data screaming in your face. You are the master shipwright of your domain. Your primary responsibility is the structural integrity. The stakeholders will not save you when the water rushes into the open lower ports. They will stand on the dock and ask why you didn't warn them more forcefully. So, I leave you with this diagnostic challenge for your next major technical architecture review. Are you building a resilient vessel, or are you just decorating a very expensive submarine?